Hello, today we will learn about binary number system and how decimal number system and binary number system are related to each. So, first to start with, let's have a look at the number system as we know it, which is our decimal number system. And in decimal number system, we use a base of 10. You guys may have remembered from your elementary school, we use a grouping of 10, but here we, just a reminder, we have a base 10. What that means is we can represent digits or quantities up to 9 quantities we can represent using single digits. So if I have here, I have in my hand, or what I have drawn is 1, 2, 3, 4, 5, 6, 7, 8, 9. And so I can use numbers from 0 to 9 or digits from 0 to 9 to represent quantities uh, which are in single digits. Okay, now if I draw one more, now it has become 10. For 10 I do not have a single digit because it's a base 10 system, and once we have 10 items, then we have a base 10. That means we have a group of 10. Now I have a group of 10, so I will represent that I have a group of 10 with no single ones. So these two digits together indicate I have a group of 10 and no more. If I add one more, then it will become 1 1. That means I have a full group of 10. Sorry, let me make it look better. Then it will say that I have a full group of 10, and one more. But here this one says I have a full group of 10 and no more. So basically each time we complete in another level of grouping by 10, we can add one more digit. So if I have 10 groups of 10, so I have tens and tens and tens, and I have total of 10 groups of 10. Then I will write this whole thing as a 100, which represent that I have three levels. First, I have no single ones, I have no single group of 10, but I have a group of tens that each has a 10. Now if I take 10 of these elements, then I will here we don't have it here yet. Here I will indicate it as one further digit on the left hand side. So each digit on the left hand side represent a new level of grouping by 10. Now so we see that when we have a base 10, the digits that we have in our hand are from 0 to 9, and as we start grouping by 10, we went to two digits. If our grouping exceeds, we have 10 groups of 10, then we have three digits. If we have 10 groups of 10 groups of 10, then we have 1,000, and so on. So let's think about if I was dealing with a base 4 system. Now let's say just a random system that I think of. I have a base 4 system. Okay, now in a base 4 system, I have, like say I have a quantity of that I need to count 1 2 3 4 5 6 7. Let's assume I have 9. Let's say we have 9, right? Now I have a base 4. That means each time I have 4 items, or I can group 4 items or a group of 4 into 4 groups. Each time I can group by 4 at the next higher level, I will write it down at a group of 4. One indicate one group of 4 items and no more. Okay, individually they are just 1 1 1 1 1 1 1, right? These are all ones. Now I cannot use the digit 4 because at that time the grouping occurs. So I can use the digits 0, 1, 2, and 3. Okay, so these are my digits because I cannot use them anything other than these, because if I use 4, no, I cannot use 4 because that indicates my full group. So let me group them, because I have to group them in 4s. Let me group them in 4s. This I can write down, this is just 2. I can use a single digit here because it's not grouping yet. So this one is a full group of 4 and no more. This one is a full group of 4 and no more. Okay, now so I have basically, now what I would do is I will add these two groups that I have, and then I will add this number as well. So what I will get is, so I get the grouping, because I cannot further group, I don't have further 4 groups, these are just 2 groups, so I can write them down. These two can be written as 2 groups, right? And then I have this 2 left over here, because here I can say 2 whole groups of 4s. So when I add them together, I get a 22, but it is in base 4, which says that I have 2 full groups of 4. And we know that 2 full group of 4s will make an 8 if you are counting by tens, and then plus 2 will make it and then that will make it a 10. So if I have a 10 base 10, it would be a 22 in base 4. Why? Because that is how the base number system works. So let's extend this concept to binary number system. So now let's talk about the binary number system. How does that work? So if I have the binary number system is base 2. That means we have to group by 2's, right? So that means I have the digits 0 and 1 only, because if we get 2 items, they are going to be grouped by 2's, and that will be actually one whole group of 2 and no more. So let's kind of count some numbers. Let's say I draw 6 dots or balls or whatever you call them. Let's say I have 6, 7, 8. Let's do 10 again, or 11. Okay, so I have 11, right? Then count 3 plus 3 plus 3, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and one more, 11. So what do we do here is, since we have to group them by by 2's, let's group them by 2's. Each group, because as soon as we reach the base of the group, each group will be a 1, 0, but this one is alone. So we have this group is 1, 0, which says that one whole group of 2 and no more, 1, 0. Then we have 1, 0 here. Then we have 1, 0. Then we have a 1, 0, right? Now, as we have these, what we can say that is, basically I can further group these to next level, because I can group these group of 2's, these group of 2's. Well, this one has no companion, but we will remember it when we come back. These we can group. So this will become another level of grouping. That means 2 groups of 2 groups, or 2 groups of 2's. And then this one would also be, because we have the next level. Now we will see, we will see, can we do a little bit of further grouping? Yes, we can. Actually, these can be further grouped together into the next level. So now we have the highest level that we have achieved is 1, 0, 0, 0, and then we have some leftovers. So we will just bring them as well. Let's add them together. I get 1, 1, 0, 1 base 2. So what we have is, when we have 11 base 10, that would be represented as 1, 0, 1, 1, 2. We can never use a digit 2 or higher in a base 2 system, because if you have 2, then you must be actually grouping it into the next number, or into the next level of grouping. Okay, if you have base 3, then you can use digits 0, 1, and 2. So far so good. Now what we want to do is, let's say I ask you all to take 137 base 10 and I ask you to convert into a binary base. What would you do? That would be tough, right? Because drawing that many balls or dots or whatever we were doing would be a little tough. So what we will do is, instead we will use the logic. What were we doing? We were taking the number or number of dots and grouping them in twos and figuring out how many full group of twos we can get. And we can achieve this by dividing it. So if we divide it, we get 68, but we also have a leftover or a remainder, just like we had in our before. So here we will kind of divide it, and remember the leftovers. 68 can be further divided into further groups. So we'll go 34, but this time we get no remainder, so we will remember that. Then we will divide 34 again. We get 17, and we are happy that we did not get any remainder. We keep dividing until we can divide, just like we were grouping until we could not group further. This time we get a remainder of 1, so be careful when you do that. Then we divide it again. This time we have a remainder of 0. We divide it again. We get 2 with a remainder of 0. We divide it again. It goes in one time with the remainder of 0. Very good. So this is what we basically get. Now what we will do is we will try to collect our numbers. So this is going to be our highest level of grouping, because this is, after all of the groupings have been made. So we have, and then we go all the way up as we have divided. So we will say 1, then we have 0, 0, 0, 1, 0, 0, 1, base 2. So that means 137 base 10 is equal to 1001 base 2. And that's how we convert the decimal numbers into the binary